Hello students, welcome to Physics with Ashwini. In the last class, we discussed about Newton's second law, change in momentum, impulse, and the related formulas and the related PYQs of your NEET exam, right? In today's class, we'll see the application of impulse, that is collision of a ball with a wall. Imagine a ball is thrown towards a wall. So there will be a collision, right? And after the collision, what happens to the ball basically? The speed of the ball changes, the direction of the ball changes. This is what basically happens. So we'll consider that. See, whenever the ball is colliding with the wall, and as I said, if there is a change in velocity, so don't you think there will be a change in momentum? Yes, right. And this change in momentum is what? Impulse. So we'll see one more formula here. We have seen the general formula of change in momentum, that is F average into time. This is what we have discussed in the previous class. And today we'll see how is the change in momentum for this collision of the ball with the wall. Okay, so imagine this is m kg of the ball. It is moving with speed v meter per second. And the angle made with the wall is theta. So just to resolve it into x and y components, let us extend this vector. This is your v meter per second. Vertically opposite angles are equal theta. Let us make an assumption that after the collision, the ball is reflected with the same angle theta and with the same speed v meter per second. See, this is initial speed. This is the final speed. We are assuming that initially and finally the ball speed is same and the angle with the wall is also same. That means what we are basically assuming is energy loss is zero. We are assuming zero energy loss in this collision. In that case, the speeds will be same, the angles will be same, but there is only change in direction of the ball. Now, how will you find out the change in momentum? What is basically the change in momentum? It is m into v final minus v initial, right? Let us apply this formula for this case. What is the x component here? M v sine theta. This is the initial momentum along x. And what is the initial momentum along y? M v cos theta. Because if you see for the v vector, this is adjacent side, so cos theta. This is perpendicular side, so sine theta. And what is momentum? M into v. So this is the initial momentum along x, initial momentum along y. Similarly, find out the momentum along x and y for final case. Final momentum along y, this is mv cos theta again. And what is the final momentum along x? Negative, so minus, perpendicular, so sine theta, mv sine theta. Now find out the change in momentum in x and y. This is a 2D motion of the ball, right? So we have to resolve it into two components. So if I take change in momentum along x direction. So what is the change in momentum? P final is minus mv sine theta. So minus mv sine theta minus mv sine theta. So you'll get minus 2 mv sine theta. And what about in y direction? Change in momentum. If you see along y, initially and finally the momentums are same. So final momentum, initial momentum as they are equal, the change in momentum is 0 along y direction. Now how will you find the net change in momentum? X component square plus y component square. So what will you get finally? Change in momentum is 2mv sine theta. First important formula. Clear? We are assuming zero energy loss. This is important. Then the speeds before collision and after collision will be same and angle with the wall also will be same. What if the energy loss is not zero? Generally, if you take the practical cases, some energy will be lost during the collisions. In such case, you have to take the initial speed as v1, final speed as v2, initial angle as theta 1, final angle as theta 2, but the procedure is same. You have to take change in momentum along x and along y. Okay, but luckily you don't have such problems in your NEET exam, so don't bother. Okay, this is the first formula. What is this angle? The total is 90 degrees, right? Because x and y are perpendicular axis. What about this angle? This is 90 minus theta. Let us assume this as alpha. So what will be the change in momentum now in terms of alpha? 2mv cos alpha. This is number 2. Or else you can just substitute sine of 90 minus theta. You'll get cos theta. We are assuming that as alpha. For simplicity, this angle is important because in your previous year questions of NEET exam, sometimes the angle is given with the wall, whereas sometimes the angle is given with the horizontal. So you have to be very clear where is this angle. Theta is with the wall, whereas alpha is with the horizontal. Horizontal means x-axis. Clear? So remember these two formulas. We'll do some PYQs. Change in momentum is 2mv sine theta. Another formula 2mv cos alpha. Fine. Rigid ball of mass m strikes the wall at an angle 60 and gets reflected without the loss of speed. That means V1 is equals to V2 as shown in the figure. Fine. Initially V, after collision also V, and this 60 is given with the horizontal. So this is your alpha. The value of the impulse imparted by the wall. So what is the value of impulse here? Impulse is nothing but change in momentum. And what is change in momentum for collision when alpha is given? This is 2mv cos alpha. Substitute, what will you get? 2 into m into v. Cos alpha is 60 here. Cos alpha is how much? Cos 60. Cos 60 is 1 by 2. So 2 cancel. You will get m into v. So answer is option A. We'll move on to next question. A body of mass capital M hits normally. That means angle is 90 degrees with the wall. So this is the wall. Ball of mass m moving with velocity v. It is hitting the wall at 90 degrees. So this theta is 90 here. And bounces back with the same velocity. That means energy is not lost. Fine. The impulse experience, same formula. Impulse is equals to change in momentum. But this time will you consider 2mv sine theta or cos alpha? This time theta is given. Angle with the wall is given. So 2mv sine theta. So 2m is capital M, V is capital V, and sine theta. Theta is 90 here. What is sine 90? Sine 90 is 1. So 2m capital V. Answer is option C. Very easy. Before solving the questions, remember the formulas, okay? 0.5 kg ball, that means mass is given. Moving with a speed of 12 meter per second, V is given. Strikes a hard wall at an angle of 30 degrees with the wall. Angle with the wall is given, which is theta here. It is reflected with the same speed. That means energy is not lost at the same angle. Very good. If the ball is in contact with the wall for 0.25 seconds, so time of contact is given. The average force acting on the wall, you have to find the average force acting on the wall. What shall we do? See, change in momentum, first formula is F average into time. This is what we have discussed in the previous class. And today's class we have seen change in momentum for collision of a ball. So it is 2mv in terms of theta, it is 2mv sine theta. But both represent change in momentum only, right? So equate them. 1 and 2, just equate them. Equate first and second formula. So what will you get? F average into time is equals to 2mv sine theta. Substitute the data. We have to calculate F average, keep it same. What is our time? Time is 0.25, right? So can I write it as 1 by 4? 0.25 is 25 by 100, so 1 by 4. So this is 1 upon 4. 2 into mass is 0.5, so write it at 5 by 10. And speed is 12. Sine theta. Theta is how much? Theta is 30 degrees. Sine 30. So just simplify now. Sine 30 is 1 by 2. So that 1 by 2 and 2 will get cancelled. 2 2 times, 2 5 times. 5 5 cancel. So on LHS you are left with F average by 2. RHS you are left with 12. So what is F average now? 12 double. So this is 24 newtons. So answer is option C. You just have to equate the two formulas of change in momentum, general formula and the specific formula for collision of a ball with wall. Same kind of question repeated again. Mass of 3 kg hits the wall at an angle of 60 degrees. So this time it is with the wall. So this is theta again. Returns at the same angle. That means energy is not lost. Impact time is how much? 0.2. So mass is given, theta is given, time is given, and speed v is given in the diagram. The force exerted on the wall. Same now, just like previous year, previous question. So equate the two formulas of change in momentum. First formula is F average into T. Second formula is 2mv sine theta. Equate them, substitute the data and simplify. So F into time is how much? 0.2. So we'll write it as 2 by 10. M is how much? 3 kg. V is how much? 10. Sine theta. So I can write it as sine 60. What gets cancelled here? 2 and 2 gets cancelled. So what is F now? If 10 goes that side, 10 into 3 into 10 into sine 60. Sine 60 is how much? Root 3 by 2. See the options, root 3 is not simplified, so keep it the same. 2 one time, 2 5 times. So what is the final answer? 15 into 10. So 150 root 3 newtons. Answer is option A. So I hope you are clear with this concept. It is just one of the applications of impulse. We'll see change in momentum formula for collision of ball with the wall, and we'll just relate it to the general formula and we'll do some problems. So this is what for today. We have seen the previous year questions also related to today's topic. In the next class, I'll discuss the change in momentum and not change in momentum, sorry, conservation of linear momentum and the related PYQs. Okay. Thank you so much. Have a nice day.